Hi folks, back today with a conservation momentum question entitled impulse in it, so we can cover two topics at once with this question. So here's the scenario. I've got a car with a mass of 1500 kgs traveling east at 54 kilometers an hour, and it collides head-on with a pickup truck that's traveling west at 72 kilometers per hour. The mass of the truck is 3,000 kilograms, and the vehicles become tangled together. Determine their velocity after the collision, and B, determine the impulse felt by the car, and C, does the truck experience more or less or the same amount of impulse and force? So a few concepts all tied together here. So let's highlight some of our stuff. So we got a 1500 kg truck going east at 54, and it collides with a truck that's traveling west at 72 kilometers an hour and has a mass of 3,000 kgs. And we want to know the velocity after the collision. So this one's a momentum question, right? Some kind of collision has happened. So let's look at what we have. The formula has A's and B's in it, but I don't like to use A's and B's because it's confusing. So I'm going to use mass, MC, for mass of the car. The mass of the car is 1500 kgs. And the velocity of the car is 54 kilometers per hour. Do I need to change these to meters per second? I don't in these because it's all tied together. When I do the impulse part, though, I do. But I'm going to do this question in kilometers per hour, and then I'll change it when I get my answers. Mass of the truck, so T for truck, is 3,000 kgs. And the velocity of the truck is 72 kilometers an hour. But remember that it's heading west, so it's a negative velocity. All right, and we're looking for the velocity after, and the two of them become tangled together, so they lock together. So this is, if you recall, the three types: elastic, inelastic, and explosions. This is an inelastic collision. There's no bouncing off each other. So look at my formula page. There's three formulas for these. I'm going to use the one that looks like this. It says MA, but we're going to use MC. So MC VC plus MT VT equals the combined mass, which is the mass of the car, plus the mass of the truck, times their combined velocity after. So it's the momentum, mass times velocity of the car, plus the momentum of the truck, equals the total mass times the momentum after. Remember, the momentum total before the system, the two momentums for these, has to equal this. Fairly straightforward question. Let's put some numbers in. 1500 times 54 plus 3,000 times negative 72. Oh, not 720, 72 equals 1500 plus 3,000 times the final velocity. So if I look at my, if I crunch some numbers here, so at this point, you can put it all in your calculator. If you're good, that's no problem. Multiply these two numbers plus these two numbers divided by 4,500. Or if you need to see another step, these two numbers multiplied together, according to my calculations, give me 81,000. These two numbers multiplied together give me negative 216,000. And these two numbers here, you should be able to do with a calculator. 4,500 V prime. Add these two numbers together, I get negative 135,000 equals 4,500 V prime. Divide by the 4,500, and I get negative 30 kilometers per hour equals V prime. So that says the velocity after the collision is 30. That's not a very nice graph, but anyway. Negative 30 kilometers per hour. And if I think about it, this one is going east. So object A is going this way. Object B, or the truck, is going west. But the truck has way more momentum, so it makes sense that it'll continue traveling to the west. All right, so that's part A. I figured out the velocity after the collision. So I'm running out of space, so I'm going to erase this. Actually, I'm going to store this. This is going to be negative 30 kilometers per hour. I'm going to erase this because we're out of space. We're going to look at part B. Part B is, what is the impulse felt by the car? So there's two formulas for impulse. J equals Ft. We don't have any time. We don't have any force. And J equals mv minus mv naught, which doesn't really match with our letters here, but we'll make them match. So this formula's out because I don't have that. So I've got the mass, and this is we're going to do them individually. So this is the car we're looking at. So we're going to look for the information about the car. And so the impulse felt by the car is equal to the mass of the car, right, which is 1,500 kgs. And it's the velocity. This is the velocity after. That's that negative 30, but we can't leave it in kilometers per hour for this. So if I do the math, I get 8.33 meters per second. So impulse has to be in meters per second because it ties with force, and force is always dealing with seconds and meters per second squared. So the final velocity is 8.33, and then I'm going to subtract the mass again times the initial velocity that it had, and of course 54 kilometers per hour. If I change that, that's actually 15 meters per second. So do the math here. I'm going to multiply these two together, and I get negative 12495. Multiply these two together, and I get negative 22,500. And I add them together, or subtract them, whichever way you want to look at it, and I get negative 34,995 Newton seconds, or meters per kilograms times meters per second. Either one of those. So that's the impulse felt by the car. If I do the same numbers over again for the truck, you will find you get the same number, just slightly different. I got it when I did it for the truck. When I did the truck's numbers, I get an impulse of 35,100 newtons, or so, not 100, 10. Why are they different? Should they be different? They should be the same. So that'll answer part C. Does the truck experience more or less of the same amount of impulse and force? Remember that impulse is equal to force times time. Because of Newton's third law, force of the truck equals the negative force of the car. So they equal the same amount of force. If they have the same amount of force, can't be in the collision any longer one and the other because they're tied together. So the time would be the same. So force is the same. Force is the same. And time is the same. Time is the same. Therefore, the impulse has to be the same. Just dragging my statement over. Like I said, I've been starting to write these out. So, let's pick one. So I'm going to erase the stuff that I just wrote down. You can always rewind and check that out before I put it there. So the velocity of the car and the truck after, because they're combined, is negative 30 kilometers per hour, or negative 8.33 meters per second if you did it that way. The impulse felt by each vehicle is around 35,000 newtons. I say that because it's a little bit less and that's a little bit more. That's simply because of this 8.33. If I went to 5 or 6 decimal places, it's going to work out to just about 35,000. The force would be the same because of Newton's third law, and the impulse will be equal because they're in a collision for the same amount of time. Again, that whole J equals Ft thing. So the force is the same, the time is the same, the impulse has to be the same. So if you have any questions, again, as always, email me or pop in to see me, and I hope that helped. Thanks.